Okay, so we start ceramic preparation from here. That we design a composition according to the required stoichiometry, and then we make measurements. It's about 5 points after the decimal point, right? So about we have accuracy of 0.1 milligram, or you can say 0.01 milligram. So exact stoichiometry can be made. Then when we take that, then we bring these here. These are disposable milk jars. These disposable milk jars contain about quarter of its volume of grinding media, which is usually zirconia or tungsten small balls. About 1/3 of acetone or propanol or distilled water, whatever we need for the mix milling of that material, and then the powder. And we place it here, and depending on the required particle size of the final powder, right? We keep it here for 2 hours, 20 hours, 10 hours. People keep it for many days if they need the final particle size. When we get that, then we take it there to the drying oven and remove the balls, the grinding media, and they are dried overnight. And after that, we just mill it a little bit with mortar and pestle system. Then we sieve them. After sieving, so that all the agglomerates or any fibers or anything which we don't want are removed, then we calcine them at 1200, 800, whatever temperature do we need for that particular composition. And calcination is basically the phase formation. Whatever phase we need, and that temperature we get from differential thermal analysis, differential scanning calorimetry, and things like that. So we know that at which temperature that particular phase forms. So we make that form during calcination. After calcination, again there is chance of agglomeration or anything like that. When we again mill them, again dry them, again sieve them, and then press them into the desired shapes, usually into pellets with this manual pellet press. After that, we polish the material. After pressing, we sinter the material, and sintering basically enhances the density of the material, because the phase was formed during calcination, but sintering is not used for phase formation. It is basically for densifying the material, for making it hard enough for that particular purpose. And then we polish them and then take it then to the properties which one we want.
I have just one question. Why, sir, you are using solvent? Is that normally we are doing the ball milling for powder.
Yeah.
You are using some solvent also.
Solvent is just bringing fluidity. It is doing nothing, because no reaction is occurring because of the solvent, right? It is just for making this fluid so that the balls are not corroded and included.
Ball milling system. Last time I was using how to use this one. Like this.
Yeah.
This is very important instrument for this. We are doing actually precision cutting.
It's micron level accuracy. So how many micron thickness do you need? It has a screw guide there, and you can set the length you want to cut. So it is very fine cutting machine, and the size, the thickness of the wheel can be changed depending on the accuracy you need. This is actually a very simple electrospinning unit, right? Here we have a medical syringe, and it is pressed from that side. Fine droplets gather at the tip of the needle, and there is a huge electric field, and that electric field pulls those droplets, and they are collected here, and then we dry them, and they are nanofibers. So it is that simple technique, but the very high voltage power supply is needed, and we do it, and we usually fit here an aluminum foil, so the nanofibers are gathered on that foil, Nanofibers is prepared are composite nanofibers because they have a binder in them, they have the other compositions in them. When we dry them and we heat them, then that removes the organic content and you are left with only the pure phase there. This is the tube furnace and we can control the environment here. If we want an oxygen environment, nitrogen environment, because usually in metals you don't need exposure to air at high temperatures, right? So we put here the vacuum pump, evacuate it and then release the gas whichever we want to it, then that is done in control environment. This is a 1800 degrees Celsius furnace, mostly used for sintering of material at high temperature. This is
You have the treatment for any nitrogen gas like this?
we have with that, not with these.
Okay.
Yeah, because yes, there we have, and they are safe when they are opened at high temperatures. But these have probably molybdenum coils, so you can't open this furnace at high temperatures. They are damaging the element. This is locally made furnace for glass melting, right? So we melt glass and it can also be opened at high temperatures. We pour the glass down and we quench it, and depending on the need, we select the speed of cooling. Increase by melting into glasses. So you can decrease the volume for disposal. Some people are using such materials for making other ceramics, which are, for example, you have pyrofluor, whose structure is completely closed, and radioactive material is basically deactivated here. So it is for waste management. It is useful for nuclear energy. This is drying furnace. This is a rasaয়নিক cleaner. These are the polishing wheels, grinding wheels. Yeah, but.
This one is very important for the cooking also. You know, the polishing.
Yeah.
So normally if you have the sample, you have to polish it. You can see here we can put the sandpaper
Yeah.
different size, particle size.
Yeah.
So this is also very important.
This is also a mill, but when it takes 20 hours or 24 hours there, you can do the same decrease in particle size in 2 hours. It is called a treated mill. It is a modern form of that mill, so it has these are all tungsten based materials. This plunger, this beaker type thing and all, they are closed properly, and it also has the same milling media and the same fluid to make it fluid so that the balls are not corroded. But this machine has given me many problems, because when the plunger is down, then it grinds some of the grinding media balls which contaminate your sample. So care must be done that it is adjusted at such a position that the balls are not grinded or corroded, because they are affecting. When you are working on sensitive material in porcelain or those type of material, it is not a big problem. But when you are doing electronic applications materials, then a little bit contamination can cause a lot of problems. This is bottom loaded glass furnace, and we made various glasses for photonic applications here. And Muhammad Ali is expert in doing that, right?
There we will create some bioactive glass to maintain and reshape it.
Yeah, you can do that. You can do it. This is our locally made saw to cut blocks, bricks, marbles, and various. It is also locally made by our staff here.
Is it working?
Yeah, they are all in working order.
This is also again the polishing.
Yeah. Polishing.
Yeah. You have to do the polishing.
We
So
hold
my
the
samples will be
polish
polished.
this. Yeah.
we hold the sample here, and it rotates, and the water is coming here.
So how are we going to hold the samples in this?
With hands we do it. There are automatic polishing machines nowadays as well.
I have the same.
you have to fix over there.
Yeah, their backside is usually glue type thing.
Achha, achha.
So it is fixed.
This is the water
No,
source.
this is not. Yeah.
Will I be needing the water source as
we
well?
fit. But when you have new one, then it fits on it.
I brought the new
Yeah,
ones. Yes.
yeah, yeah.
No, that one is actually, this is not,
2000.
that one is not for this one. Actually,
Yeah,
this is,
But can it be,
we can, no, we can buy
shape
for
it.
this one also.
Yeah.
We can buy for
محمد
this
علي
one.
ده ترى نمي اشتا
جي شتي مختلف سايزز ولا شتي فاين دايموند باليشنग
नहीं 800 ना दे 2000 में सर 1000
नहीं नहीं वो तो ठीक है लेकिन असल में खबर अदा वाला चीदा दे पर स्पेशल है कभी सेंट पेपर देगा ना जिसका फॉर्मेल वाले पर
sticky
मैं बोलूँ शी
हाँ the sticky bake ये देगा ना
sticky.
sticky you fix it
वाटर रश का ऑटोमेटिकली स्टक شيء
صحيح.
هذا
وزمان صار تكون سامبلز دي بس نقدر كنا أقبل لك كبير
ده 400 ना غالبا तर 1200 पूरे ده great size है ना और बियांगा सुई वर्ता diamond paste अगर 6 micron 1 micron 3 micron a quarter micron. So how much fineness you want, you decrease the micron size of the paste. So we put a cloth upon it, a cloth, and that diamond paste then grinds the material very fine. This is the fume hood, and students are working inside when they are using some gaseous material which are harmful for their health, so they use the fume cover. And the sample you see around, they are from the mountains of Kailash. I had a project with America and 4 PhD students and a couple of MPhil students who gathered all these samples and they completed their MPhil and PhDs, unknowing their own mineral wealth. Yeah.